Okay, so I'm going to explain the physicsy concepts of kinematics and calculus. So basic kinematics combined with basic calculus. So this is my velocity equation. It's just a basic regular equation that's going to represent velocity. And then in this question, I'm going to find my position. I'm going to find my position when my initial condition, when time equals 0 and my position equals 5. So that's shown by this coordinate. And then I'm going to find acceleration, my maximum velocity, and when my object stops as other parts of things you can find with your velocity. So we'll start with position. Okay, position is the integral of velocity. So that means you can take your velocity equation and you can take the integral of it to find position. So here, position equals the integral of t squared minus, okay, sorry, this marker is trash. T squared minus 2t minus 3. And when you take the integral of that, you pull down, you add 1 power, so that's t cubed, and then you pull down this. So since there's no coordinates, it's constant, it's 1. And then you do squared, and you pull that down 2 over 2. Then you put this down 1, 3. So this is going to be, plus c, this is going to be my position equation. And then the way that you find c is you use your initial condition. So here, when t equals 5, s of t equals, when t equals 0, s of t equals 5. So you do 1/3 times 0 cubed minus 0 squared minus 3 times 0 plus c. So you can find that c equals 5 because all of these go up to 0 and it leaves you with that. So your final position equation equals 1/3 t cubed minus t squared minus 3t plus 5. Okay, that's one thing you can find with velocity. Another thing you can find is acceleration. So over here I'm going to do acceleration. Acceleration is the integral, the derivative of velocity. So that means you take this equation over here and then you find the derivative. So a of t equals t squared minus, d dx, minus 2t minus 3. So that means a of t equals, you pull down the 2, so 2t minus 2. And then that's going to be your acceleration equation. And the next one we're going to do is finding the minimum velocity. So when you find extrema in velocity, if I draw a velocity graph, which is velocity over time, if I find a minimum, it's going to be over here. And since this is slope at that point, the slope at that point is 0. So it's the same thing as saying the derivative is 0. So since the derivative of velocity is acceleration, you can find where acceleration equals 0. So I would do 0 equals 2t minus 2. That means t equals 1. And then this is going to be when your derivative equals 0, but you have to make sure that it's a minimum by using a number line. So here if I use a number line and I plug in 0, I'm going to get something negative. And if I plug in 3, I'm going to get something positive. So that means over here it's decreasing because when the derivative is negative, when acceleration is negative, velocity is decreasing. And here it's positive, and when acceleration is positive, velocity is increasing, so that means this is a minimum. So you can say there is a minimum at time equals 1. You can say second. And then lastly, I'm going to find where the object stops. So that means when the object is at rest, so you would say velocity equals 0. So the way that I would find that is I take my velocity equation and I just set it to 0. So here, 0 equals t squared minus 2t minus 3. So you would just do basic factoring and find your 0. So you would do t minus 3 and t plus 1. So t equals 3 and negative 1. And then you have to use your number line. Well, no, since this is when the object stops and it's in time, time can never be negative. So you know this one is wrong. So that means your final answer is going to be when t equals 3, the object is at rest. And that's it for basic kinematics and calculus and things you can find with a velocity equation.